Today is Monday, October 23rd. Let's go ahead and get started. So, if you are watching this video and you are absent today, so you're watching not because you want to summarize, if you want to summarize, you just want to review, go ahead and fast forward to the sections that you need to listen to. If you are absent, I need you to have your plate boundary comparison chart ready to go. If you were not here for the last couple of days, this is in the folder that was for Wednesday and Thursday of last week. All right, before we begin, I just took the kids very quickly through kind of a snapshot of our week. We've got a busy week coming up. And I'm going to be gone on Wednesday, so I wanted to kind of go over some things just so if you have any planning issues that you can kind of put in your mind what's coming up. So Monday today we're just going to go over Plate Motion 2.4. Homework is to study Chapter 1 and Chapter 2, vocabulary and key concepts. Tomorrow we'll finish almost finish Chapter 2. And that's when we're going to evaluate some evidence, and then you guys are going to use RAISE to write a scientific argument answering the Chapter 2 question. Now, this is not a summative, this is a formative, so it's just a practice for you to write your scientific argument using really strong evidence. Your homework is, if you are not able to finish that writing in class, then you need to finish that and then go ahead and study your vocab and key concepts. If you are in HAL and you signed up for the enrichment activity, remember you need to watch the summary video in today's folder, or I guess in tomorrow's folder, so that you're able to finish that activity. You are responsible for getting this done, even though you're going to be gone in class. So Wednesday, we're going to do something called our mid-unit assessment. This is not graded. However, if you score 90% or higher, you may choose to keep that score as your end of the unit assessment. And then I have an independent project that you can work on for the rest of the unit. So while other kids may be finishing up Chapter 3, you've demonstrated that you've understood the entire unit, because you've got to, in order to get 90%, you have to score almost 100% on PB 1, 2, and 3. So that demonstrates that you have understood the unit, you're ready to test out, and then you can work on an independent project. You still need to take the vocabulary and key concept test, and there is a summative, a scientific argument at the very end of this unit, and you will need to write that. I am going to be gone in the morning. I have to go to a meeting, and then I'll be back around 11:45, so I'll be back for advisory. And then today, because we had that mid-unit assessment, if you don't want to, you can take a break from studying vocabulary. If you are one of the students that has not really started studying vocab, then you may not want to choose to take a break on that. You need to use all the time you can, okay? Now, Thursday, before I go over Thursday, I want to remind you, if you're in choir and you're my fourth period class, you will not have class today because you've got that rehearsal. But you are responsible for this information. This might be a little bit challenging for you to do just based on a video. So watch the video for Thursday's folder, and then I'll have all of the information for you, and make sure that you have an opportunity to work with somebody so that you can get that finished, okay? All right, so we will be doing the very last unit, or the very last lesson in Chapter 2. And this is a targeted review and exploration. I'll explain more about this later, but basically, based on the data from the mid-unit assessment, you are going to be matched with another person at your PB level. And so you've got some different activities that you and that partner will be working on and amplify. Maybe you need some time to review. If I need to reteach, whatever, that is going to help you get ready for Chapter 3. If you scored in that 90th percentile for the mid-unit assessment, then I will meet with you after I get the review group started. And then homework for everybody is going to be to study vocabulary and key concepts. And then on Friday, if you have the independent project, you guys just need to check in with me, and then you'll go to the computer lab. And then everybody else will get started with Chapter 3. and that's called Investigating the Rate of Plate Motion. All right, let's go ahead and get started. You know what? I just want to go back. The reason why I'm sharing this whole week is because there's a lot of weird stuff happening and a lot of different people working at different levels and some people gone. And this week is going to be challenging. And so I encourage you to just kind of review this and make sure you understand what's happening. And if you are gone, whether you get sick or whether it's for choir or HAL or whatever, you are responsible for that day's information. Whether we did anything, if I assigned a homework assignment or not, you need to know what we talked about. So you have to watch those videos, okay? All right, so let's go ahead and get started. We're finishing up lesson 2.4, and we're going to go ahead and finish this investigation question. What happens to the plates in the mantle at the plate boundaries? So we're going to jump to activity 3, and this is exploring plate boundaries in the sim. So Monday is a short day, so I'm rushing through this. The sim mission has 2 parts. So pay close attention to the directions, okay? So when we were in class, I just kind of talked to the kids. I said, okay, so for part 1 of the sim, you're going to create 2 different scenarios. The first one in which rock is being added to the edges of both plates. And then the second is one in which the plate sinks into the mantle. So they're purposely not going to tell you which plate boundary to push. But if your goal is to have rock being added to the edges of both plate, which plate boundary would that be? And then the same for the second one. So the kids worked with a table partner. You can go ahead and get started by yourself. So you're in activity 3, and make sure you're in screen number 1. And you're going to see that there is a data chart kind of for you. And so the very first thing that you have to do is you need to make a prediction. And so it's going to ask you, which plate boundary do you think you'll want to push if you want to create a scenario in which rock is being added to the edges of both plate, and then which plate boundary would you choose if you wanted to create a scenario in which the one plate sinks into the mantle. So go ahead and make your prediction, and then come back and keep playing the video. Okay, so now that you have your prediction, let's go to the second. These are your directions on your screen number 1. It says, on one device, open the plate motion sim. You are your own person. You won't be able to work with a partner because you're working on your own. So just be aware, and you may have to just do a split screen or just toggle back and forth between the 2 open tabs. So you're going to select region 2, and then the first mission is to set up a region so that the rock from the mantle will be added to the edges of both plates. We're going to add rock to the edges of both plates. Or if you want to, it doesn't matter which one you choose, or create a region in which a plate will sink into the mantle at the plate boundary. So then you're going to press set boundary to choose that plate boundary type. Again, notice I'm not telling you you're going to create a convergent plate boundary, or press that convergent plate boundary, or press the divergent plate boundary. This is a review activity. I'm hoping that you know which one is which, especially after filling out that compare and contrast chart. And so go ahead and pick one, and then press run and observe what's happening in the cross view. And if you are seeing rock being added to the edges of the plate, or if you're seeing one plate sinking into the mantle. Okay, so that's the end of that step. Once you've finished watching all of that happen, then you need to press build and repeat steps 3 and 4 for the opposite scenario. So whatever you chose in number 3, pick the opposite one the next time you run it. And then you're going to complete the statements below based on your observations. Okay, I kind of want to skip this. Well, actually, I don't. I'm going to have you stop this video, go ahead and run the sim, and then come back. Please don't cheat. Really do this. Please. If you don't do it, you're just writing down the answers, and it's a good way for you, a kinesthetic way for you to check your understanding and make sure that your predictions are correct. There's no way I can guarantee that you actually did this. So do yourself a favor and really do it. Don't just watch the video. Okay, hopefully you did the sim. So let's go ahead and go through what we found. Number 1, you saw that rock from the mantle is actually added to the edges of both plates at divergent plate boundaries. And that's where the plates move away from each other. And then hopefully in the next scenario, you saw that one plate sinks into the mantle and is destroyed at convergent plate boundaries. And that's where the plates move towards each other. So now we're ready for part 2, the sim mission. And in this part, you're going to add to your knowledge of patterns at plate boundaries. So that picture to the left, that should remind you that we had that one activity where we used the map, where we had the transparency paper, and you guys were supposed to trace the plate boundaries, which are the red lines there, in 4 different boxes. And then you laid the earthquake map on top of that, and then you were supposed to trace the dots. And we noticed then that earthquakes happen at or near plate boundaries. Well, we're going to test that now. So I just wanted to remind you, before you get going too far in this sim mission, make sure that once you set up your plate boundary type in the sim, that you quickly toggle on the active volcanoes and the earthquakes toggles there. Notice, by the way, that this says not just volcanoes, but active volcanoes. So on your compare and contrast sheet, we had a box down there that asked if there were active volcanoes, or actually it said, was there volcanic activity at both of these plate boundaries? And we're going to test what we think is going to happen, because to be quite honest with you, we can infer what we think from the article that we read. But to be honest, if you read paragraph 6, it kind of implies that there might be volcanic activity at convergent plate boundaries, and some people were kind of confused. And so this is a really good way for us to test our inference and how we read that article. So here's what you're going to do. First of all, you're going to open region 2 and then use the add rock tool to add continents to the map. Okay, number 3 says set boundary, press set boundary, and select divergent as the plate boundary type. We're going to hit divergent first. Go ahead and press run, and then very quickly toggle on your earthquakes and volcanoes, active volcano button. You want to really pay attention. Observe whether earthquakes and volcanoes occur at the plate boundary. In other words, where that lime green line is, are you seeing earthquakes and active volcanoes? Are you seeing the black dots and the red triangles? Okay, what can you see in the map view and what's in the cross-section view? And make an observation how the cross-section view changes. What landforms are associated with this type of plate boundary? Okay, so with the divergent plate boundary, what landforms are being made, and what is there? Are there earthquakes? Are there active volcanoes? All right, once your time runs out there, then you're going to repeat your observations with a convergent plate boundary and complete all of that comparison chart. Make sure, your comparison chart should be done. Just look at it and make sure you don't need to make any revisions. Now, this one, I am actually going to take you to this because I want to run it for you. I want to talk about it with you because I want you to see what I was sharing with the kids. Okay, so we're going to choose region 2. We're going to go in and build a continent. So I'll do something here. I'll do something there. I'm going to do my set boundary. They wanted us to choose divergent first, so I'm going to do that. Notice as soon as I hit divergent, what landform popped up right there at the plate boundary? That is a mid-ocean ridge, which is a mountain. Okay, so now let's go ahead and hit run, and then immediately I'm going to toggle on earthquakes. All right, so you can see that the active volcanoes and earthquakes are both showing up on the plate boundary. On the plate boundary. So does divergent plate boundaries, do they have earthquakes? Yes. Do they have active volcanoes? Yes. Great. All right, so I'm going to click build. I'm going to rebuild. And I'm going to make a continent here and a continent there. I'm going to set my boundary and I'm going to do convergent. So we have another little continent that shows up there, and that's fine. Notice, what do you see in the cross-section view? What is the landmark, or I'm sorry, not landmark, landform that was created here? It is a trench. Okay, now I'm going to hit run and then toggle very quickly, and I want you to see what happens. Because those plates are moving towards each other, the earthquakes are occurring at or near the plate boundaries, but the plate's moving. So it doesn't appear, it appears that the earthquake is kind of a little bit behind it. Okay, I'm going to redo this, and I want to show you. Now pay attention to the active volcanoes because this one is very important, okay? So let's go ahead and hit run, and you'll see that the active volcanoes are never at the plate boundary. They are always near it, and in fact, kind of, it's on the plate that is on top, and it's always, let me show it again, and it is always, okay, sorry, I forgot to do that. Reset time. Okay, so that active volcano is always on the top plate, and it's never at the plate boundary. It's near it, but it's never at. And we'll learn why. We'll kind of understand why that happens here in a little bit. The other thing I want to show you too is, I'm going to reset my time one last time to show you this kind of fun thing. So watch in the cross section. Watch hopefully it happens. Watch the length. I have a train that's going by my open window. Hang on one second. I'm going to shut this real quick so you can hear me. Okay. Now I don't even know if it happened. Nope, it didn't happen. That's okay. Okay, so with this new information now, we're going to go back and we are going to take a look at that compare and contrast, the plate boundary comparison chart, and let's double check our information. So looking only at the last 3 boxes down there, the landforms that are commonly found at or near the divergent plate boundary. Now, the divergent plate boundary, remember, is the one where the plates are moving away from each other and new hard solid rock is being added at the edges of both plates. So that creates a mid-ocean ridge. And we also saw, when we toggled on the active volcanoes, we did see that there were volcanoes there at the plate boundary, because it says, are they commonly found at or near this type of plate boundary? Yes. Okay, so then compare that to, I can't remember now. I think I'm doing convergent plate boundaries next. I may have gone all the way down. Let me double check here. Yes. So at convergent plate boundaries, the landform is a trench because the one plate goes on top of the other plate. And then again, we did see near this plate boundary, we did see volcanoes. Great. So now what about earthquakes? Do they occur at divergent and convergent plate boundaries? Yes, they do. This last one is the tricky one. And this is the one that we have to really, really make sure, and you may need to revise this. It says, is there volcanic activity at this type of plate boundary? Not at or near, but at. And so divergent plate boundaries, we saw active volcanoes, but convergent plate boundaries, we saw them, but they were near. They weren't at. So the answer is no. So the great thing here is you've got some background information that later on I'm going to give you some information about the plate boundary between South America and Africa so that you can come back here and make a determination as to which type of plate boundary that is. So this is really important to make sure that you revise this and so that you can use it later on. All right, we've got 2 key concepts I want to go over. Key concept number 6 is just discussing what happens at divergent plate boundaries. So at divergent plate boundaries, rock rises from the mantle and hardens, adding new solid rock to the edges of both plates. And then key concept 7 says at convergent plate boundaries, one plate moves underneath the other plate and sinks into the mantle. Now, there's one last thing I want to do. There's an exit ticket that I had the kids do today. If you go to our folder today in Schoology, you're going to see this PDF called Modeling Convergent and Divergent Plate Boundaries. Go ahead and copy that into GoodNotes. It's 2 pages. And if you look at the picture there on the left, you see the first page has a cross-section view of convergent and divergent plate boundaries, but there's a square, there's like a section of that cross-section missing. And the second page shows cross-section options, okay? What you're going to do is for each plate boundary, you're going to add a cross-section that best represents what's happening where the 2 plates meet. So I want you to use your lasso tool, and on the second page, you're going to circle the correct cross-section option, and then go ahead and press copy. And then you're going to paste it on page 1 in the square there for the right cross section. I want the kids to show me before they left the classroom today. I just want you to show me when you return. Okay? So your homework today is to make sure that you have this finished, as well as making sure your comparison chart between the 2 plate boundaries, make sure that's correct. I believe I asked you to turn that in. I had the kids turn that in today, and so make sure that you turn yours in as well. All right? If you have any questions when you come back, please let me know, or you can email me. But the number one thing I'm going to ask you is, did you watch the video in its entirety? It's a long one today. And if you say, oh, no, I didn't watch the video, I'm going to make you watch the video, and then we can talk. All right? I will talk to you hopefully soon.